This video is going to be about solving distance problems with known Kerner rate and unknown time. These are going to be the harder types of distance problems, and we're going to need rational equations. So I'm going to just say using rational equations. Now there are a few relationships I want to remind you about. First of all, we know that rate times time equals distance. So we've been using that throughout the semester. But sometimes we don't want distance to be by itself. Sometimes we want rate or time to be by itself. By the way, this equation can be written d equals RT. So my example was, what if we want to get rate by itself? Then I can just divide both sides by time. So I'm going to divide both sides by t, and I end up with the rate equals distance over time. Finally, if I want to get time by itself, then I divide both sides by the rate. And so this gives me time is equal to distance over rate. This is going to be very important for doing these types of problems, and we're going to be using the same exact table that we did before, rate times distance, except sometimes we'll have the rate and the distance filled in, and so we need to get that time. Or vice versa. You'll see when we do some examples. Remember also that if our boat is with the current, and so the boat is traveling with a current, if the speed of the boat, so let me just say x equals speed of boat, and y equals the speed of the current, then if the boat is with the current, then the speed is equal to x plus y. What about if the boat is going against the current? If the boat is going against the current, then it's going to be x minus y, since the current is hurting you. By the way, if you're going with the current, another way to write that is downstream. So anytime you see the word downstream, it means you're going with the current, and this is called upstream if you're going against the current. All right, let's do a couple of examples and figure out how these work. Number one. With a current flowing at 3 miles per hour, a boat can travel 9 miles downstream. In the same amount of time, it can travel 6 miles upstream. What is the speed of the boat in still water? Okay, so we're looking for the speed of the boat. So let's let x equal speed of the boat in still water. Let's go ahead and draw our table, as I love doing tables. So we have upstream and we have downstream, right? So it mentions downstream first. I'm going to go ahead and write that one first. Downstream and upstream, and we have rate, we have time, we have distance. Now, if the rate, well, what do I put for rate downstream? Notice the speed of the boat is what we're looking for. That's x. But it says the current is going at 3. So that means that the speed of the boat downstream would be x plus 3. Remember, it's going to be the speed of the boat plus the speed of the current. Upstream, since we're going against the current, it's going to be x minus 3. Okay. Now what? Well, it says when it's going at 3 miles an hour, going upstream, it says it travels 9 miles downstream. 9 miles downstream. So this is going to be 9 miles downstream. In the same amount of time, it can travel 6 miles upstream, so that's going to be a 6. Now, I'm missing the time. However, recall from earlier, I said that time is equal to distance over the rate. Okay, time equals distance over rate. So if I just take the distance and divide it by the rate, I get 9 over x plus 3. On the second line, distance over rate would be 6 over x minus 3. Now, it says it does it in the same amount of time. That means that the times must be equal. 9 over x plus 3 equals 6 over x minus 3. The LCD here would be x plus 3, x minus 3. By the way, notice our restricted values, our bad values here are 3 and negative 3. So x can't be 3 or negative 3. We multiply both sides by the LCD, so x plus 3, x minus 3, and we're going to do that on both sides. So on the left, we end up with 9 times x minus 3, and on the right, we end up with 6 times x plus 3. We get 9x minus 27 equals 6x plus 18. Subtract 6x from both sides, add 27 to both sides. We get 3x equals 45. Divide both sides by 3, we get x equals 15. Remember, that's the speed of the boat in still water. So I write speed of the boat is 15. 15 what? Miles per hour. All right, let's try another one. The speed of a boat in still water is 10 miles per hour. If the boat can travel 9 miles downstream in the same amount of time it can travel 6 miles upstream, find the speed of the current. Notice in this problem, they give us the speed of the boat and they want the speed of the current. We're going to start by letting y equal the speed of the current. You don't have to use x and y the way I do. I just like to use x for the object that's moving and y for the current. So let's let y equal the speed of the current. Let's create our table. Again, we have downstream, we have upstream, we have rate, time, distance. Now, it says, let's see here, let's get the facts here. The speed of the boat in still water is 10 miles per hour. So how fast is it going downstream? It's going to be 10 plus y. And what about upstream? Well, it's going to be the speed of the boat minus the speed of the current, 10 minus y. By the way, a big mistake students make is they always think that it's going to be y plus 10, y minus 10, because that's what it was in the last problem. Keep in mind, you always have to add the current or subtract the current. In this case, since the current was the variable, that's what you're adding or subtracting. But in the last problem, for example, the current was known. That was the 3, right? So we were adding 3 and subtracting 3 from the variable. These are differences, and they will lead you to the wrong answer if you do it wrong, so be very careful. Now, what about the distance? Well, it says it can travel 9 miles downstream. Same amount of time, it travels 6 miles upstream. This is a very similar problem that we just did. And the difference is, of course, that we have the 10 plus y and the 10 minus y. Now remember, time is equal to distance over rate. Okay? So, the distance over the rate and the distance over the rate. Now, it says in the same amount of time. Let's not forget that sentence. So we're going to write 9 over 10 plus y equals 6 over 10 minus y. Again, the bad answers are plus and minus 10. Now, our LCD is 10 plus y times 10 minus y. So we're going to multiply both sides by 10 plus y, 10 minus y. I'm going to go ahead and write it like this, just so I can do my cancellation separately. In the first one, the 10 plus y's cancel. I'm left with 9 times 10 minus y. In the second one, the 10 minus y's cancel. We're left with 6 times 10 plus y. So we get 90 minus 9y equals 60 plus 6y. Let me rewrite it up here just so I can show my work. If I add 9y to both sides, and I subtract 60 from both sides, I end up with 15y equals 30. Divide both sides by 15, I get y equals 2. Remember, that is the speed of the current, which is what we were looking for. So speed of current is 2 miles per hour. Okay, let's do one more. This is going to be a hard one. Tim drives 80 miles from Detroit to Lansing and later drives 60 miles more from Lansing to Grand Rapids. The trip from Lansing to Grand Rapids takes him a half hour less than the drive from Detroit to Lansing. Find his average driving speed if it's the same on both parts of the trip. This is definitely a tougher problem, and it's a little bit different than what we've been doing since there's no current he's going against or anything like that. Okay, so let's figure this out. It says find his driving speed. So we know we're looking for that. I'm going to start by saying let x equal the driving speed. Okay, that's what we're looking for, right? Okay, so we're going to create our table. The first one says it's from Detroit to Lansing, so I'm going to say D to L. And the second one says it's from Lansing to Grand Rapids, so L to GR. We have rate, we have time, we have distance. Okay. Now, we know that the rate, the driving speed and the rate, that's the same thing, and it says it's the same on both parts of the trip. These are both going to be x. Now, it says that it's 80 miles from Detroit to Lansing, so this is 80 miles. And then he drives 60 miles more from Lansing to Grand Rapids, so this is 60. Now remember, time is equal to distance over rate. That means this one's going to be 80 over x, and this one's going to be 60 over x. However, here's where the problem changes. It does not say that it takes the same amount of time. In fact, it says the trip from Lansing to Grand Rapids takes him a half hour less than the drive from Detroit to Lansing. The trip from Lansing to Grand Rapids takes him a half hour less than the drive from Detroit to Lansing. So let's think about that. Since the trip from Lansing to Grand Rapids is the smaller time, because that took him a half hour less, then that means, the smaller time is Lansing to Grand Rapids. That's this time. So I'm going to write this time. Now, this is smaller by a half hour. So that means if I add a half hour to that, I'm going to end up with the other time. The other time was from Detroit to Lansing, right? So that's going to be 80 over x. By the way, why did I choose a half and not 30 for 30 minutes? Well, everything here has to be in miles, hours, and miles per hour. So since we're talking about hours, 30 minutes would be half an hour. I have to write it as 1/2. So this is my setup. It really helps in problems like this to think about it. Is it true that Lansing to Grand Rapids plus a half is equal to the other? It has to be, right? Because the trip from Lansing to Grand Rapids takes him a half hour less. It's very easy to mix up which one you have to add the 1/2 to. Now, the LCD, well, first of all, what are the bad answers? The bad answer is x cannot be 0. So the LCD is 2x. So I'm going to multiply everything by 2x. And in fact, I'm going to write it like this, just so I see 2x next to everything. For the first one, the x's cancel, and I'm left with 120. For the second one, the 2's cancel, I get x. The third one, the x's cancel, I get 160. Subtract 120 from both sides, I get x equals 40. Now remember, this is your driving speed, so the answer is 40 miles per hour. Okay, hopefully that was useful. The main thing that we learned in this video is the fact that we have the distance equals rate times time formula, but we also have rate equals distance over time and time equals distance over rate. We especially used this one a lot in these types of problems. Thanks very much for watching, and I hope that this was useful. See you next time.